Welcome to this training video for Project Atlantis. This video is about DevSecOps in Atlantis, or how we achieve resilience in the framework's deployments. In the context of large-scale projects, software integration is vital as it enables seamless collaboration between diverse systems and applications, ensuring they work together harmoniously. It streamlines workflows, enhances efficiency, and fosters a cohesive environment where data and functionalities can be shared across the project, reducing redundancy and maximizing the overall effectiveness. We'll dive into the world of DevSecOps in Atlantis, exploring its importance, benefits, and the technologies and tools involved. Here's an outline of what we'll cover. 1. Objectives of the presentation. 2. Importance and benefits of DevSecOps in general. 3. Background of the technologies and tools used in Atlantis. 4. Explanation of main principles and technical specifications of the technologies and tools. 5. Practical examples in the context of Atlantis. 6. Benefits and challenges. 7. Summary and key takeaways from this video. Let's get started. Our objectives today are: first, to understand the significance of integrating security into DevOps workflows. Second, to explore the technologies and tools crucial for implementing DevSecOps in Project Atlantis. Third, to learn the principles and best practices for ensuring resiliency in deployed services. And finally, to gain insights into practical applications and real-world scenarios of DevSecOps in the project. DevSecOps isn't just about merging development, operations, and security, it's about infusing a security mindset throughout the entire software development lifecycle. Here's why it's crucial. Ensures early detection and mitigation of security vulnerabilities. Leads to improved collaboration between development, operations, and security teams. Results into enhanced resilience and reliability of deployed services. Reduces the risk of security breaches and compliance violations. Achieves faster delivery of secure software with automated processes. The DevSecOps process applied in Atlantis is depicted in this figure, where it is clear that the security aspect spans across all steps of the process: plan, create, verify, package, release, configure, detect, respond, predict, adapt, and the monitoring and analytics running in the background. Let's explore the background of the technologies and tools used in Atlantis. Kubernetes, a container orchestration platform for automating deployment, scaling, and management of containerized applications. GitLab CI/CD, a continuous integration and continuous deployment platform integrated with GitLab for automating the software delivery process. SAST Static Application Security Testing and DAST Dynamic Application Security Testing. Tools for analyzing application code and identifying security vulnerabilities. The figure shows the 4 phases of the software development lifecycle in Atlantis and how these technologies and tools mentioned are utilized in the SDLC. These technologies have evolved to meet the growing demands of modern software development, offering scalability, automation, and security. Now, let's delve into the main principles and technical specifications of the tools used. Kubernetes. Scalability, portability, and declarative configuration are achieved through YAML manifests. These YAML files describe various components of the deployment: exposed service if any, employed storage, config maps, and secrets with important deployment information, for example values for environment variables, and jobs for necessary initialization and other recurring tasks. The deployment of the custom applications requires these files. GitLab CI/CD. CI/CD is a technique that involves automating app development stages in order to regularly deliver apps to customers. Continuous integration, continuous delivery, and continuous deployment are the key ideas associated with CI/CD. In the context of the Atlantis platform, GitLab CI/CD pipeline is used and further adapted and extended for the purposes of the project. In software development based on continuous method, the developers continuously build, test, and deploy iterative code changes. This iterative process helps reduce the chance that they develop new code on buggy previous version. This method will lead to less human intervention from the development of new code until its deployment. The pipeline's configuration is achieved with YAML files, as depicted in the screenshot, where various stages including build, test, SAST, DAST, and deployment are included. SAST and DAST. Static code analysis for identifying vulnerabilities in the source code. Dynamic testing for detecting security issues in running applications. We'll explore these concepts further with some examples. Here are some practical examples of how and why these tools are applied in Atlantis. Automating containerized application deployment with Kubernetes. Integration with GitLab CI/CD pipelines allows for automated building, testing, and deployment of containerized applications to Kubernetes clusters, ensuring rapid and consistent delivery of updates. Kubernetes monitors the health of application pods and automatically restarts or reschedules failed instances, maintaining high availability and resilience. The first screenshot shows a Kubernetes deployment in Atlantis, which includes the components of the CCI SOM. Integrating SAST and DAST scans into GitLab CI/CD pipelines for continuous security testing. Integrating DAST and SAST into CI/CD workflow involves incorporating these techniques seamlessly into the development pipeline. SAST tools analyze source code for vulnerabilities without executing the program, and they can be integrated into CI/CD by automating scans during the build process, providing immediate feedback to developers on code changes. DAST, on the other hand, tests running applications for weaknesses by simulating attacks and can be integrated into CI/CD by automating tests against staging environments, ensuring that applications are assessed for security issues before reaching production. Orchestration tools within CI/CD pipelines schedule and execute these scans at relevant stages, while unified reporting and policy enforcement ensure that identified vulnerabilities are promptly addressed and compliance standards are met before deployment. The second screenshot depicts a CI/CD pipeline of an Atlantis component, which includes SAST scans. Using Kubernetes for rolling updates and scaling to ensure service resiliency. Kubernetes supports rolling updates, allowing new versions of applications to be deployed gradually without downtime, ensuring seamless user experience during updates. It also enables horizontal scaling of applications by automatically adding or removing pods based on demand, ensuring optimal resource utilization and performance. The third screenshot shows the updates of an Atlantis component and how these are handled by the defined CI/CD pipeline. These examples illustrate how DevSecOps practices can enhance security without sacrificing development speed. While DevSecOps offers numerous benefits, it also comes with its own set of challenges. The benefits are enhanced security posture, faster time to market, and improved collaboration. The challenges, on the other hand, complexity of implementation, skill gap among team members, and cultural resistance to change. Understanding these benefits and challenges is essential for successful adoption. In summary, DevSecOps in Atlantis is about integrating security into every phase of the software development lifecycle. By leveraging Kubernetes for deployment and GitLab CI/CD for automation, alongside SAST and DAST for security testing, we can achieve resiliency in deployed services. Key takeaways. Early security testing mitigates risks. Collaboration is key to success. Continuous improvement is essential. Thank you for joining the DevSecOps training for Project Atlantis. Let's make our software more secure and resilient together.